there's a link for all batch details, so you can check for other batches also. Then there is our Facebook page. So during the demo session, we're going to be live on Facebook. Then there's our YouTube channel link. So many sessions are freely available there on YouTube. You can also watch that. Let me go live on Facebook. Then I think we can start with the session. Yes, Satyam, I think we can start.
Okay, thank you so much, Rajan sir. And now we shall start with the session. So once again, hi everyone, a very warm welcome to all of you from the Olympiad Success family. So today, kids, as you all know, we are going to have a demo and introduction program for grade 7 science. And the flow of this session would be like, first of all, there would be an introduction by your mentor who would be taking up this entire course for you. Then we would be having a short presentation about this course. Okay, so all the details about this course would be mentioned by Rajan sir. I will be then taking you through the tour of the platform. Post that, we would be having a short question and answer round. Okay, so if you have any queries, you can write it down in the chat section and then we can answer your queries. And post the question and answer round, we can start with the demo session for which you all are here. So all our live classes are of 75 minutes. Today's session is also of 75 minutes. But then since this is a demo session, so specifically the demo part would be of around 40-45 minutes because the other part we would be taking up for the introduction. Okay, all right. So kids, now let me introduce you to Aishwarya ma'am. She has been associated with us for a long time now. And science is her forte, I would say. And kids really love her classes. So Aishwarya ma'am, why don't you give a brief introduction about yourself to the students?
Thank you, ma'am. All right. So hi, everyone. My name is Aishwarya and I am from Delhi, but I do keep moving around all over the place. Now, like Aati ma'am said, I have been associated with Olympiad for quite some time now. But apart from that, I have been taking or I've been teaching for competitive exams for almost 4.5 years now. And I have an MPhil in botany. So my major forte, of course, is science and bio. So I hope all of you come to these classes with a curious mind, right? All I want from you is not just sit there and stare at me. I want all of us to interact with each other, right? Have a good time and learn something new in that process. All right. So no sitting quietly, ask as many questions as you want so that it becomes easier for me also to get to know you. And of course, you'll see me almost every alternate day, right? So I hope all of us have a lot of fun together. Thank you, ma'am.
Yes, absolutely. Thank you so much, Aishwarya ma'am. And it's always a pleasure to have you on the platform. So I see one child already writing in the chat box. Jilsha, I know you, Aishwarya ma'am. So there is already a student of yours, I believe, in the class. So students, now I would like to request Rajan sir to give a brief presentation about the course.
Sure, ma'am. Let me share my screen with the students. I hope my screen is visible. Welcome students. Welcome to the demo interaction program for class 7 science. Firstly, let me tell you about us about Olympiad Success. So Olympiad Success is India's largest online preparation platform for Olympiad exams. We have Olympiad live classes and we also have School Plus program. So in School Plus program, we offer 8 courses that are mathematics, English, science, logical reasoning, communication, spoken and written both, Vedic maths as well as coding. What else, students? We also offer one-on-one online CBSE, ICSE, IGSE, and IB classes for grades 2 to 12, and one-on-one preparation classes for International Mathematics Olympiad, like SESMO, CMO, HKMO, TIMO, Math Count, US Math Competition, Math Kangaroo, and PRMO. Now, students, meet the rank holder for session 20 to 23 and 21-22. So many students in Olympiad Success got international ranks in various Olympiad exams. Okay. Now, students, about this course, so there will be around 20 students in the class and the classes will be conducted on Zoom platform. So there will be 3 sessions per week. The days will be Monday, Wednesday, and Friday. And class timing will be 5 p.m. to 6:15 p.m. Okay. So the class duration will be of 75 minutes. The session include mix of theory, practice session, doubt session, and we will also discuss previous year papers. Students, you will get reading material and practice questions, which will be available on the dashboard of Olympiad Success. And with this course, you will also get free access to the science and logical reasoning topic-wise mock test that is available on the Olympiad Success dashboard. Okay, students? Now, the syllabus link I will share within the chat box. The fees for this course is 12,044, and there will be 54 session in this course. Payment link I will post in the chat box. So the fee include online classes, daily reading notes and exercises, practice of previous year paper. And like I said, you will also get access to the Olympiad Success platform for science as well as for logical reasoning, topic-wise mock test. Okay. Now to join this course, what you need a laptop with good internet speed and laptop or desktop with camera, as we don't allow students without video in the classes, and headphone. Students, as you already know, like preparation for Olympiad exam is tougher than your regular school curriculum because there will be some questions and concepts from your upper grade also. So hence students will be required to spend approx 2 hours every day to cope up with the curriculum, and parent support will be needed to check answers and retrieve concepts. So students, live classes for this course, we are going to start from 12th May. And currently we having students from 3800 school, and we are catering in 35 plus countries. So this is about this course, student. Now Aarti ma'am will give you a tour of Olympiad Success dashboard. After that, if you have any doubt or query, we will take that. Okay. So over to you, Aarti ma'am.
Thank you so much, Rajan sir, for a wonderful presentation. And now let me quickly share my screen and I'll take you through the dashboard of Olympiad Success. All right. So kids, once you enroll with us for this program, you would be getting your credentials, that is your email and password, using which you can log into our website, olympiadsuccess.com. Just go to the login page, enter your credentials and click on the sign in button. You would be redirected to the profile page. Okay, so on the profile page, make sure your profile is complete and then only you can move to any other section on your dashboard. So there are two important sections wherein you can access your material. So first is the live classes. So on this live classes page, all the subjects would be coming up for which you have enrolled. So right now, like these many subjects are coming because I've enrolled to all these subjects. Since this is science, let me click on science. And then let me select the topic. So let's say I'll select the topic fiber and fabrics. Okay. So here the reading material, practice question and answer keys are given. I'll click on, let's say, reading material. So all these three are available in the form of PDF. Okay. So as soon as you click on the links, a PDF would open up and then you can study from these PDF, right? The next thing is practice questions. Okay. So for your practice, we have provided these practice questions per topic. They would be available. So you have to just mark your answers and then finally you can match your answers with the answer key given here. Okay, so you have to just click on that and again a PDF will open up and then here the answers would be displayed. The next important thing is the view schedule part. So as soon as you click on it, again a PDF opens up. So here, as you notice, like all our sections. So how many sections we do have? We have 54 sections in this course. Okay, and in each session, as you notice, like we have a topic. So what we would be covering up in session 1, what we would be doing in session 2, session 3, so on and so forth. As you notice also, like after every topic or two, we would be taking up a test. All right, so we would be giving you a test which you have to do so as to make sure that you and the mentor align and they are on the same page. Okay, so whatever your mentor is teaching, you are understanding each and everything. Then we have the holiday calendar on this page. You can see the dates on which the classes will not be conducted. And then finally your Zoom meeting ID and password, it will be displayed here. Okay. Next is the worksheets part. Okay, so Rajan sir had mentioned that you would be getting topic-wise free worksheets for science and logical reasoning. You have to just go to the worksheets page, select your subject, and then here you can see the topic-wise worksheets are given. So there are 105 worksheets available for you for your practice. So for acid and base numericals, there are 2 worksheets available. In each worksheet, there will be 25 questions. So these would be available in the form of test. You have to just click on the take exam button to start with the test. And then to view your answer keys, you have to just go to the performance tab, select your subject, and then click on the view button and your answer keys will open up. So this is all about the platform. Now, if you have any queries, we can take them up one by one. So you have to write it down in the chat section. Any doubts, any queries coming up, students? Come on, at least there will be one query. No queries.
Okay, so students, in that case, let me ask some questions. Can you tell me the days on which you're having the classes? You can post in the chat box. Monday, Wednesday, Friday. Okay. Any other answer? Is it correct? Okay. Yes, the days are Monday, Wednesday, and Friday. And what are the class timings? 5 to 6:15, but it is AM or PM. Need to mention unit also. Yes, PM. Okay. So students, do anyone have any query regarding the course or anything? No? Okay. So shall we start with the session then? Yes. Okay then. So let's start the session. So over to you, Aishwarya ma'am.
Thank you, sir. All right. Just before I start, I would like to request all of those people who have their videos off to switch on their videos. It would be nice to see some more faces on screen. I can only see 6, 7 students' videos on. Could you please switch on your video? As mentioned, if when you come for regular classes, you'll not be allowed to sit without your videos on off in class. So please switch on your videos. All right. Okay, once in a while, if your network is not working or your camera is not working, that is okay. But please have your videos on because it's nice to see some faces on screen. All right. Okay, I think a few of you switched on. All right, thank you for those of you who switched on your video. All right, so today we'll be talking about light. Okay, so just let me share my screen. Okay. Can someone tell me about light? You can raise your hand. I'll ask you to unmute yourself. Anything that you know about light, what is light? Or if I say the term light, what comes into your mind? Everybody knows what is light, right? Everybody's seen light. We have lights at home. We see the sunlight. But what is it? No one? Give it a try. All right, good, Asha. Yes, Asha, what do you think is light?
Light is a form of energy.
Anything else? Yes, Ananya, anything else?
Yes, ma'am. Sorry, ma'am. Ma'am, a source of energy or a brightness which allows us to see things around us is called light.
Hello?
Ma'am, am I audible?
Yes, now you're audible.
Yes, ma'am. Ma'am, the brightness or the source of energy which allows us to see things around us is called.
Good. Is called light. Absolutely correct. Yes. Okay, one more student. Let's see what Sobin has to say. Yes, Sobin.
Ma'am, it is also an artificial source of light.
Okay, correct. So light, first of all, light is a form of energy, right? Secondly, light enables us to see anything that we are able to see. So if there is no light, let's say you're in the darkness, of course, during nighttime or if there's no light, you'll not be able to see anything, right? So light will allow us to see things. Now, when it is allowing us to see things, there is, of course, a source of light as well. So the ultimate source of light is sunlight for all organisms on Earth, right? But we can have natural sources of light. We can also have artificial sources of light. Okay, so first of all, light is a form of energy. And normally, the light, when you talk about light, light always travels in a straight line. This is very important because that is how the light can reach us through a particular distance, travel a particular distance from space. That means the light that is coming from your sun, that is reaching our earth or reaching us, because it can travel in a straight line and it doesn't get scattered in between, right? So if we say that light is traveling in a straight line, we call it rectilinear propagation. Okay, rectilinear means, recti means in a straight, linear means line. So rectilinear propagation means whenever the light is traveling in a straight line, we call it a rectilinear propagation. Now, light takes the quickest path between any 2 points. That means, let's say this is point A and this is the source of light. Okay, and this is point B. Let's say this is you and you are seeing this light. So the light will not travel to you like this, or it will not travel to you like this. It will take the shortest path between these 2 points. That means it will take the shortest path like this, right? So that you can see the rays of light quickly. And that is how we've also postulated that light travels in a straight line, because straight lines will usually be the quickest. Now, normally, if you have to check whether or not the light travels in a straight line, we have a small little demo or an experiment that we usually do, which is this one. So what we've done is we've taken a candle, all right? We've placed 3 cardboards and we've made holes on these 3 cardboards at the same place. All 3 of them have it at the same height and they are placed in front of each other, right? Then what we do is we observe this candle from a far end. So these cardboards are A, B, and C. We are observing the candle from here. What we can see is that the beam of light can be seen straight coming out from these cutouts. Now, if I move this B cardboard little slightly upwards, what will happen? This cutout will go upwards. Will I be able to see the light? No, right? Right. Why? Because light is traveling in a straight line. So if the cutout is moved upward here or downward or any other direction, what will happen is the light will get blocked and I will not be able to see it. So this is a demonstration which shows that light always travels in a straight line. Okay. Any doubts so far, anyone? All right, let's move forward there. All right. So like I said, there can be different sources of light. So we can have natural sources of light and we can have artificial or man-made sources of light, right? So the natural source of light, of course, is the sun and the stars. And artificial or man-made sources of light would be everything that is around us. So the electric bulb, the torches, the tube lights, fire, candle, burning candle, they're all man-made sources of light. No matter what the source of light will be, whether it is natural or whether it is artificial, light still will travel in the same straight line. Light is still a form of energy, right? It doesn't change. Now, depending upon whether an object has a natural light of its own or not, we can categorize the objects into 2 different types. One is a luminous object. Second is a non-luminous object. Luminous objects will be objects which have light of their own and they're emitting that light or heat. Okay, those are luminous objects. Whether they are natural or artificial, both. All objects which are emitting out light are luminous. So whether it's a tube light, whether it's a burning candle, or whether we're talking about the sunlight, they are all luminous. Non-luminous objects would be objects which do not have a light of their own. So human beings are non-luminous. We don't have a light of our own, right? Earth, all your planets, trees, let's say a bottle, a pen, pencil, they're all non-luminous objects. Any doubt till here, anyone? Yes, no? Don't know anyone who's lost as to what is happening? I hope not. All right, let's move forward then. Okay. So these are certain examples of luminous and non-luminous. So this is luminous, this is non-luminous. So the sun, the fire, a lighted bulb, they're all luminous objects. Your pen holder, brushes, cardboard, moon, they are all non-luminous objects. Okay, so moon is a non-luminous object. So how do we see the moon lighted up? We can see the light of the moon, right? Yes, Bhavya.
And we can see the light of the moon because it reflects the sunlight.
Correct. It is reflecting the light that is falling on it by the sunlight. So whatever portion of the sunlight is falling on the moon, that portion we can see. That is why we can see different phases of the moon, right? Every day, every monthly, we have different phases of the moon. Correct. All right. So can someone tell me which all objects are luminous, which are non-luminous? There's someone who's not answered. Asha, Ananya, they've already answered. Bhavya, you've also answered. Anyone who's not answered? Now, when you come to my class, I'll be picking out on names also, even if you don't raise your hands. All right. Anyone wants to give it a try, maximum you'll be wrong. There's nothing wrong about being wrong. Yes, Pratham. Tell me the luminous objects first.
Ma'am, the luminous objects are the candle, the sun, and the torch.
Sure, candle is a luminous object.
Yes, ma'am. When we light it, it glows.
But is it burning right now?
No, ma'am.
So will it be luminous or non-luminous?
Ma'am, it would be non-luminous.
Only non-luminous. What about the torch? Is it on? Is it off?
Ma'am, it's off.
Non-luminous.
So it's non-luminous.
As of now, only the sun is luminous. Why? Because this is off. This is also off. So if I have a torch placed in a dark room, obviously it is not emitting any light, right? If it is on, then it will be a luminous object. If it is off, it's a non-luminous object. Got it, everyone? Rest
Yes.
everything is non-luminous. Okay, good. All right, let's move forward. Okay. Now, whenever we see any substance or any object, some objects will allow light to pass through them, and certain objects will not allow light to pass through them. So on the basis of interaction of different substances with light, we have three types of objects. First, transparent, second, translucent, and third is opaque. Transparent objects allow all the light to pass through them. Whatever light is falling on them, all the light can pass through it. Then it is called a transparent object. For example, a glass. All right, it's a transparent object. Translucent object will allow some light to pass through it. So maybe a butter paper, a tissue, or let's say some kind of plastic. They will allow some light to pass through it. So it's translucent object. Opaque objects are objects which do not allow any light to pass through it. Okay, so any solid object which is not allowing light to pass through it. So for example, a table, a book, a human being, we are all opaque objects, right? Any doubt, anyone? Yes, no, okay, no problem. Let's move forward then. Okay, so these are different examples of transparent, translucent, and opaque. So transparent, this is a, let's say, a glass pane window, so, or a door. It's completely transparent. This is your tissue or a net curtain, so it's translucent, and a dark curtain would be completely opaque. Asha, do you have a doubt?
Yes, ma'am. Ma'am, I have a doubt. Is mobile and luminous object?
Mobile would be a luminous object because it is, it does have a light of its own. So devices which can light up, your laptops, your TV, your mobile phones, they're all luminous. Okay. All right, let's move forward. Now, yeah, so this is another example basically. So when all the light is passing through it, we are calling it transparent. Some light is passing through it, translucent, and no light passes through it, opaque. All right. I hope no one has a doubt. Certain examples are given here. Normal reading glasses. It's a magnifying glass. This is a glass jar, window pane, glass candle holder. They're all transparent, translucent, a smoky or a foggy day, a window pane which has plastic, dollar bill. These are all translucent. Opaque, rest everything which is solid, watermelon, cherry, ice cream, pie, cake, they are all opaque objects, right? Now, whenever we see any substance or any kind of object, why are we seeing it? Because light is falling on it, right? Let's say if it's a dark room, you'll not be able to see anything. Normally, if you're sleeping in the dark or during night, you don't see the objects in your room, correct? But if your light is switched on, then you will see these objects because light is falling on it and these substances are reflecting that light that is falling on it, because of which we can see the substances. So reflection of light is the phenomena of bouncing back of light in the same medium on striking the surface of the object. Now, why same medium? That means we are talking about if we are seeing something in air or the light is being the source of light is in air, the object needs to be in air and the light will get reflected back in air only. It will not go somewhere else. Okay. Because if it goes, so for example, if I'm looking at myself or I'm looking at my reflection in a lake. If you see your reflection in a lake, what happens? It's sort of a distorted image. It's not a very clear image, right? Because the medium is changing. You are standing in air and the moment you see your reflection, that reflection is in water. So there is some kind of distortion, there's some kind of movement. So we will talk about that also, what happens and why does it happen. So there's a slight change in how the reflection is perceived. But when we are talking about the normal reflection of light, we are talking about it in the same medium, right? Now there are a certain, there are a few terminologies that you need to know. So this is a reflection shown on a plane mirror, okay? Now, why do we call it a plane mirror? Because firstly, the surface of a mirror is usually plane. That means it's a smooth surface, correct? Plane mirrors are mirrors that you have at home, your dressing mirrors. They're all plane mirrors. Does anyone know how a plane mirror is made? How do you make a plane mirror? It's very easy. If I have to convert a piece of glass into a mirror, how do I do that? It's actually a piece of glass only. How do you do that? Any idea? Give it a try. No? No one knows? So you take a piece of glass and I paint it silver, I do a silver polish on it on one side. So it becomes a reflective surface, right? It is quite simple. It is simply how, like, if you have these metal objects at home, or let's say a nice spoon or a steel plate, that also reflects your reflection, right? So in that similar manner, what we're doing is we're taking a piece of glass and we're simply polishing it on one side, and the other side, the opposite side, becomes a reflective surface. Now, this is a plane mirror. The light that is coming, the ray of light that is coming from the source is known as the incident ray. Okay. Now, when the incident ray will fall on the plane mirror, this incident ray will be bounced back or will be reflected back. So the reflected ray is the ray of light that is bounced back from this plane mirror. And this is the one that we will eventually see. Because of this reflection, we can see the object in the mirror. Okay. Now, to see or to have an understanding of where the reflected ray will go, what we do is we make an imaginary line which is perpendicular to the plane of the mirror. That means if this is a plane mirror, we've taken an imaginary line which is perpendicular to this plane. This imaginary line is known as the normal. This will allow us to figure out where exactly can you see the reflected ray, right? So let's say if I play now, this mirror is horizontal. Now, if I put the mirror like this and the incident rays coming in like this, perpendicular to the surface of the mirror, we will make the normal this way. Okay. So it simply we have to take it perpendicular to the surface of the mirror, nothing else. So how will we know that where is the reflected ray going? We'll know because the angle of incidence, that is the angle between incident ray and normal, which is represented by small I. This is angle of incidence, will always be equal to angle of reflection. Angle of reflection is between normal and reflected ray. So this angle. So angle of incident will always be equal to angle of reflection, and that is how we will know where exactly is the reflected ray going. So if this I is 30, R is 30. I is 90, R is 90. I is 60, R is 60. Okay. Now a lot of numericals come on this. They can ask you that if there are two mirrors placed, 3 mirrors placed, how will they get reflected? So simply in that case, what you have to do, you will have to follow a little bit of maths. Like I'm sure you've done triangles in maths. So what angle does a triangle make? Like what is the total angle? What happens if one angle is 90 degree? What will be the rest of the angles? If it's a isosceles triangle or what kind of triangle, that way you'll have to find the certain angles. When we come to your regular classes, then we will do some numericals. As of now, we're not doing any numericals today. Okay. Otherwise, we will do some numericals when we come to the regular sessions. Any doubt in this? This is particularly for plane mirror, reflection in a plane mirror. Because reflection of different types of lenses or different types of mirrors, for example, a concave mirror and a convex mirror will be different. The rules are slightly different, okay? Any doubt? Shall we move forward? All right. Okay, so normally when we see, okay, before I move on to this, yeah, so normally when we see a reflection in the mirror, what do you see? You see yourself straight only, right? I hope nobody's seeing themselves upside down in the mirror. If I look at myself in the mirror, will I be able to see myself erect? Yes. What is the change? The change is only that there is some kind of lateral inversion. That means my left becomes my right becomes my left, correct? If I raise my left hand, my right hand will be seen in the mirror. So there is only lateral inversion, but the image is erect. So normally there are two types of images. Now understand this carefully because this is important when we do convex and concave mirrors and lenses and what kind of images are formed. So understand, and then if you have a doubt, you can ask. So there are two types of images. We have real images and we have virtual images. And as the name suggests, real images are actually real in nature. That means the reflected rays are meeting somewhere in reality. So we call them real images. Real images will always be inverted. Virtual images will always be erect. Okay. So how do you know that an image is erect or it's an image is real or virtual? By seeing that it is inverted or erect. So for example, if you see this picture, can you see this is the tree and the tree is inverted in the lake? Yes, you see it upside down because this is a real image. And the image that you're seeing of yourself in the mirror, that's a virtual image because it's erect. Now, what exactly do you mean by virtual and erect image? Let me just go back to the previous slide. All right. Now, when you see the incident ray and the reflected ray, of course, there is not a single ray of light that is coming from the source, right? There'll be multiple rays that will be coming, right? We are taking one just for our understanding, right? And similarly, all these rays will be reflected back also. So when they're going back, they're all parallel in nature. So when they're parallel to each other, we're just talking about reflected ray right now. So all these reflected rays, R1, R2, R3, R4, they're all parallel to each other. If they're parallel to each other, will they ever meet in reality? In wherever they go, even if I take this to infinity, will they ever meet? No, right? So what we do is we take a estimate, or there is a virtual image that is formed. So in reality, they are not meeting, but behind the screen in the mirror, somewhere they might be meeting here. Okay. So in reality, they're not meeting, but virtually they are meeting. That is why if the source is here, if I am the source, I'm standing here, my image will also be here inside the mirror. I don't see my image here, no, outside the mirror. I hope nobody's seeing themselves behind themselves, right? So you see yourself inside here. So it's a virtual image, okay? If it's a real image, in the real image, what will happen? I'll just give you an example. We will talk about it when we come to regular classes. So normally, let's say if it's a convex mirrors are usually like this. That means the reflective surface is curved. So if it's a convex mirror, what will happen? If the ray of light is falling here somewhere and reflection happens, there are chances that these reflected ray might meet somewhere in reality. Then the image will always be inverted because it's a real image. It is meeting in reality. We are not imagining it to meet. Got it? Any doubt? Till now, you just have to know this much. When we talk about the convex mirrors, concave mirrors, and the lenses, then we look at all the ray diagrams and understand how and where the ray of light is meeting, and accordingly, what kind of images are being formed. Till now, is there a doubt in real and virtual images? Okay, great. Okay, so can anyone tell me? So we have, so before I move on to this, we have a convex lens in our eyes. Okay, I'm telling you this. So we have a convex lens. That means it looks something like this. Right, and this is the light coming in, and eventually the image is formed. There's a screen, the eyeball at the end of the eyeball. So let's say this is the eyeball. Here we have a slight screen, and then the image is formed here, and a signal is sent to the brain through the nerves. Okay. Now, can someone tell me, do we see virtual images or do we see real images? Do we see a real image or do we see a virtual image? If someone is standing in front of you, do you see that person erect or inverted? Smash, you can answer. Do you see people standing in front of you erect or inverted? You see them erect. Yes. But we are seeing in our mind, not in our mind, in the screen and the eyeball, we are actually seeing real images. Our brain will convert it into a erect image. So basically what is happening is when the light passes through our lens, the image is concentrated and the image will be formed somewhere here like this. All this light will go inside because we don't have a mirror in our eye. We have a lens. What does the lens do? Lens will allow the light to pass through it. Correct? So here there will be an image formed which will be real only. But when the signal is sent to the brain will again make it inverted, allowing you to feel that you're seeing it in the erect way. Okay. This is what we do in your projector screens also. You know, we've seen projectors. Always remember, a real image can be observed on a screen, but a virtual image can never be caught up on a screen. So your image, the one that you see in a mirror, the dressing mirror, that can't be caught on a screen. Okay? Because inside whatever you're seeing, that's completely virtual. Okay, it's not real. So if it's coming on the screen, that means it's real. So when the projector projects this light or the images on screen, that is a real image. But again, it is erect. Normally you see erect picture. No, I hope when you go see, make sure that they're all erect. Basically, in the projector, only the film is playing upside down, so that when it is played on the projector, it becomes erect for you to watch it. Got it? Anyone who's confused? Yes, Jinsha. You have a doubt? You can unmute yourself. All right. So let's move forward. Jinsha not unmuting herself. Okay. So see, this is how, sorry, this is how you see a reflection. This is the source. Light is getting reflected back, but we will see the image inside the mirror, right? Because it's a virtual image. Now, these are a few of the things that I explained earlier. So incident ray is AO. This is the ray of light that will fall from the source. Then reflected ray is the ray which bounces back from the surface, which is OB. Then normal is an imaginary perpendicular line drawn from the plane of the reflective surface. So this is NO is the normal. Angle of incidence is AON, which is the angle between incident ray and the normal. And the angle of reflection is between the reflected ray and the normal. So that is BON. Now, if you see, they have made this marking, right? This fringe-like structure. This just shows which is the reflective surface and which is not. So let's say if I've drawn it like this, that means this is the polished surface wherever this thing will be there, these lines. This is the polished surface and the opposite side will be the reflective surface. Got it? So in this case, of course, this is the reflective surface and this is the polished side, just for your understanding. Any doubt here, anyone? Okay, let's move forward. Okay, these are the few rules or the laws that I told you earlier. So the angle of incident with respect to the normal is always equal to the angle of reflection that we've already done. So I will always be equal to R. Second thing is incident, normal and reflected ray, they all lie in the same plane. Okay, it is not that incident ray will be here and reflected ray can be here or here. No, they will all be on the same plane. And third rule is that incident ray and reflected ray will always be on opposite sides of the normal. So if incident ray is coming from here, reflected ray will be on the opposite side of the normal. Let's say incident ray is coming from here, then reflected ray becomes on the opposite side. Whichever side you want to take, it's fine. It's not a hard and fast rule that the incident ray has to be on the left side. This is just for your explanation. Okay, any doubt in these laws? Very important. No? Okay, great. Let's move forward then. All right. Now, another thing about reflection on a plane mirror is that normally whenever we have a plane mirror, if the plane mirror is flat and smooth, only then will you see all the reflected ray going back parallelly to each other. So incident ray that is coming from the source, that will obviously be parallel to each other because they are coming from the source. There is no disturbance in between. Once they strike the surface of the plane mirror, or the reflected surface, if it is smooth, then all the reflected ray going back will also be parallel to each other. Okay, and they will give you a regular reflection. So it is known as a regular reflection on a smooth surface. However, if the case is different, so let's say if I go to the next slide, in this case, where the surface is not smooth. So in this case, what is happening is that the incident ray, again, incident ray will all be parallel to each other because it's coming from the source and the source has no disturbance in between. So incident ray will always be parallel to each other. That is, there is no exception to that. But If the surface is not smooth, then the reflected rays can go in all different directions. That means the reflected surface will not be parallel to each other, and that can give you a distorted image or any kind of unbalanced image, which is an irregular reflection. And that is exactly what you can see in some of the reflective surfaces, which are not as smooth as a plane mirror. And sometimes even in your plane mirrors, you might feel that some mirrors you might look a little taller, you might look a little shorter, you might look a little fatter or thinner. Because that is because the image is distorted. It's not a very good quality mirror, right? And sometimes, those illusion houses or illusion places that you visit, there also you can see distorted images. It is because of this only. And it can also happen that you might not see the image completely, because these reflected rays are going here and there, and they might meet somewhere else in reality. So a virtual image might not be formed. So there can be some cases where in that mirror, you're not seeing the actual reflection as well. So these are usually used for different kinds of tricks and, in these different illusion houses and everything. But most of the time, your plane mirrors will give you a perfectly regular image. Okay. Any doubt, anyone? No? So this is how it will look. Regular surface, all the incident rays are parallel to each other. All the reflected rays are also parallel to each other. And on the other hand, this is an irregular surface. The incident ray will be parallel to each other, but all the reflected ray are going here and there in all different directions. They are not parallel. Okay. A few rules about, or a few things about the images formed by a plane mirror. First of all, an image that is formed by any kind of light or any image that is being formed by a particular source, that can have, or it will emit light in different directions. Now you have to perceive that direction. So basically the reflected ray can go in all different directions depending on the surface and the light source. Second thing is that whenever the light is getting the light strikes on a surface, the reflected ray will try to converge. That means they will try to meet. But if it's a plane mirror, we've already seen it's a plane mirror, all the reflected ray goes back parallelly. That is why they are not meeting. So if they are actually meeting and actual convergence happens, then we call it a real image. And real image will always form on a screen. That means you can get the real images on the screen. And that is how all your cameras, your photographs, everything works. Okay, we will talk about it in detail when we come to the regular classes. On the other hand, a virtual image will not meet ever. They will just have a apparent convergence. That means a virtual convergence, and they cannot be obtained on a screen. That is why all the projector screens and everything, all the projections that you see, they are all real images. Okay. Any doubt, anyone? All right, so normally on a plane mirror, we've already discussed, you see a virtual image. The real object is here, reflected rays coming back, but somewhere here, virtually, the image is being formed because virtually the reflected ray might be meeting. Now, if there is an actual intersection of ray of light, then we call it a real image. And surfaces, plane mirror will never give you a real image. Convex mirror, concave mirror at different situations can give you real images or virtual images. Again, this we will discuss in detail when we come to the regular classes. Okay, as to how and when can you obtain a real or a virtual image in a convex mirror, concave mirror, and convex lens and concave lens. Now, these are some features of the images that are formed by the plane mirror. First, a virtual image is always formed by the plane mirror. We've already discussed this. So another thing, image formed by the plane mirror is always erect because it's virtual. Second, the image is the same size as the object. That means if you're 4 foot tall, 5 feet tall, the image will also be 5 foot tall. It doesn't happen that the image becomes 6 feet tall or 2 feet tall, right? It's the same. Size, length, height, everything remains the same. Width, everything remains the same. Image is laterally inverted. Like I told you, left becomes right, right becomes left. Fourth, distance of object from the mirror is always equal to the distance of the image from the mirror. If you are standing 4 meters away from the mirror, your image will also be standing 4 meters away from the mirror. Okay, it doesn't appear nearer or further away. It's the same distance and it is always virtual. So few of easy numericals can also come on this. I'll give you one slight little numerical so I understand that you've understood or not, and then you can give me your answers. Okay, so let's say this is a plane mirror. Okay, this is an object. Let's say a candle is placed here, right? And it is about 3 meters away from the mirror. And from here, you are viewing the image. So this is where you're viewing it from. You are almost, again, 2 meters away from the candle. Listen to the question carefully. At what distance will you see the image? This is you. At what distance will you see the image? You can raise your hands and give me the answer. So an object will be formed. So image is formed here. This is the object. This is you. At what distance will you see the, or how far is the image from you? An easy question. You can put it in the chat also. Okay. Someone is saying 5 meters, 5 meters, 8. Pratham is saying 8. Uh, 5, 8. Okay. All right, most of you are correct. Yes, what about others? Take a guess. Maximum you'll be wrong. It's okay to be wrong. We're all here to learn. Quickly, everyone, please answer. What do you think will be the distance or how far is the image from you? Then I'll allow one of you to answer. Okay. So most of you are correct. Ananya, Manasvi, Pratham, correct. Yes, Pratham, would you like to explain how?
Yes, ma'am. Ma'am, when the candle gets reflected towards the mirror, it also covers the distance. So that's 3 meters. Then when the candle again gets reflected back towards your eye, first it gets reflected 3 meters and then 5 meters. So now if we calculate 3 plus 5 is equal to 8 meters.
Yeah. There's a simpler way. You are here. You are already 2 meters away from the object. The image is forming 3 meters inside the mirror, correct? So simply add all of this now. 2 plus 3 plus 3. 3 plus 3, 6. 6 plus 2, 8. So 8 meters. So your distance from the image becomes 8 meters. Correct? Those of you who got 5 meters. Any doubt, anyone? All right, great. So these kinds of questions can come. Okay, Jilsia had asked me that how do we know that, how can we see different, how many times does the image is formed when we have 2 mirrors face to face? So I will talk about it in a little while. I'm coming, that's the next topic actually. That if you have more than one mirror, what is the number of images that can be formed? Any doubt here, anyone, so that I can move forward? Any doubt? No? Okay, that's it. Okay, so this is just how your images are formed. So height will be equal. H1 and H2 are always equal. Height is same, width is same, distance is equal. A will always be equal to B. Only thing is it will be laterally inverted. So if it is something like this, Omer, and this will appear the other way around. And that is why sometimes, most of the time, nowadays it doesn't happen that frequently, but most of the times we see that in front of the ambulance, the letters of the ambulance is written in the in backward way, so that when you're seeing it from your rear view mirror, you can see it straight. That means you can read that an ambulance is coming behind you, so that you'll give them way. So usually it is written on the, like normally we write it from left to right, it is written right to left. Okay, so questions like this can also come. Last year only a question that placed in front of the mirror. What do you think is the reflection? What kind of reflection will you get? What is the image that you will get here? So it is laterally inverted, right? So this B, first we look at this B, this is the nearest. This B becomes like this, correct? L will become this, U remains the same, and B again like this. So different options were given. For example, something like this was given. This was given. This was given. And this is given. So you have to select the correct option, right? So sometimes these are very easy questions, but people do tend to get confused. So don't get confused. Take one by one, take one letter at a time, and then start converting. Now, another question was asked last year that out of the following alphabets, which one doesn't show lateral inversion? So alphabets which will not show lateral inversion mostly will be, for example, U doesn't show lateral inversion, U will be U only, right? Similarly, A will be A only in the mirror. I is I, right? H is H. So O is O. So things like this can be asked. Got it? So just read the question carefully and you'll be able to, yeah, symmetrical letters, correct, will not show any kind of inversion. Any doubt, anyone here? No? All right. So this is what I was saying. This is how it's usually written on the vehicle, and then you can see this on your mirror, so that you can see exactly the. Okay, so these are certain uses of the plane mirror. This we already know. We use it in our dressing rooms for looking glass. We use it in the trial rooms. We also create false illusions through them. We can use it in a kaleidoscope, periscope, and solar cookers, right? Okay, now coming to this. This is slightly important. Now, this is the last topic for this session. Try to understand, don't copy and all, you can do that later. A lot of numericals come on this. So normally if there are more than one mirror placed in a particular position, how do we find out that the number of images that will be formed by that particular mirror? Now, usually you can be given 2 mirrors, 3 mirrors, 4 mirrors also, but focus on 2 mirrors. Mostly 2 mirror questions will come, but sometimes three mirror also come. But mostly the third mirror will be parallel to one of the mirrors, so the images formed will be not that great. So let's say if you go to a trial room, normally when you go try on clothes and go into a trial room, we have minimum of 2 mirrors in it, so that you can see yourself from the back, also from the side, from the front, everywhere, and you know how any clothing material is looking on you, right? So how many number of images can be formed? Of course, it's not infinity. It's, you do see image inside an image, but there is a fixed number of images. So how will you find out the images? First, find out what is the angle between the 2 mirrors. So let's say this is mirror number 1. This is mirror number 2. So first we'll find this angle. At what angle is this placed? This angle is called theta. Theta is just an abbreviation It doesn't have a value. So let's say theta here in this case is equal to 60 degree. Then what you'll find out is you'll find out what is 360 by theta. So let's say in this case, theta is 60. What is 360 by 60? Quickly calculate. 360 by 60. Theta can be any number. Let's say this is 90. Theta is 90 here. It's 6. Correct. So 360 by 60 is 6. Now, if 360 by theta comes out to be an even number, like in this case, it's an even number, it's 6. So what will you do? You will subtract 1 from this. And this is the number of images that you will get when two mirrors are placed at an angle of 60 degree with each other. Got it? Now let's say in some case, if 360 by theta was odd. Most of the cases it will be even, but let's say in some case it is odd. Let's say it comes out to be 3. You leave it like this. This is the number of images that is formed. Okay. Now sometimes it can happen that the 360 by theta is not a complete number. That means it is a fractional number. Then what we'll do, let's say 360 by theta has come out to be 3.5. There is nothing known as a 0.5 image. A mirror will never form a 0.5 image, right? Not a half an image of you will not be formed. So we'll take the whole integer only. Even if it comes out to be 2.9, we will take the number of images as 2. Got it? Any doubt? If the 360 by theta comes out to be even, we subtract 1, and that is the number of images that you will get. If 360 by theta is odd, we will simply leave it like that. That is the number of images that you get. If 360 by theta is in points or in fraction, we will take the whole integer. We will not take the point. Now, it also depends on like what we do and what kind of, if we subtract 1 or not in an odd integer or an even integer, also depends on where exactly is the image placed. Sorry, where exactly is the object placed. So that when we come to regular classes, then I'll explain. That means, let's say if this is the mirror, it is at 90 degrees, so theta is 90 degrees, and the object is placed somewhere here. Then maybe the number of images can change because, you know, this is closer to this. It might not be reflected completely here. So the image formed by this is not getting reflected completely here. So this also makes a difference. 2, if the object is placed here. If the object is placed symmetrically, then the number can change because here equal distance is maintained from both the mirrors. So what will happen is that the reflection of, so let's say this is the first mirror, reflection that is coming on the first mirror will act as an object for the second mirror also. So in this case, the number of images will be different. And in this case, the number of images can be different. Because here, if let's say the reflection is being formed here, this might not act as an object for this. So that can also differ. That we'll discuss when we come to the regular classes. As of now, whatever I've explained this much, have you understood? Is there any doubt here? Anyone? Anyone who's not understood and wants me to explain again? 100% numericals will come on this. Yes, Ananya?
Mama, as you said that if we divide 360 by 60 and after subtracting 6 by 1, we'll get 5. We'll get 5 images formed. So how 5 images can form on just 2 mirrors?
Because the reflection of one will act as an image object for the other, no? So if let's say these two mirrors are here, right, with 60 degrees. Let's say this is the object. This object is giving a reflection here. So whatever is the reflection, that can act as an object for this mirror. So
Yes,
this is
ma'am.
also an object now, and this is also an object. That is why you see yourself multiple times in the mirror. So like
Oh,
this, it will get reflected back and forth. And once it is getting reflected back and forth, maximum 5 images can be formed, not more than that. Okay.
thank you.
All right. Okay. So let's move forward. So this is how this is placed at 90°, and that is how we calculate. So this is what it is happening. This is also an object now. This is also an object. So that is why you can see multiple images. Okay. Now human eye, I'm not going to do because human eye will take a little bit of time. So I'm just going to skip human eye. We can do the questions quickly. Human eye will do when we come to the regular classes. Okay. Can you guys answer these questions quickly? Send me a direct message. Don't send it to everyone so that everyone gets a chance to answer. Which statement is true for the reflection of light? Angle of incidence and angle of reflection are equal. Reflected light is less bright than incident light. Send it to me, please. Direct, don't send it to everyone. Send a direct message. Sum of angle of incidence and reflection is greater than 90 degrees. It should be, not 900. The beam of incident light after reflection diverge at unequal angles. Yeah, first one is true. Angle of incidence will always be equal to angle of reflection. Good. Okay, next. Due to the reflection of light, the impression of an object formed in a mirror is called dash of the object. What is it called? Image, shadow, light. Due to the reflection of light, the impression. Good, Rajat. It is called, yes, it is called an image. Very good. Next. Which of the following is a natural source of light? Electric lamp, tube light, torch, the sun. Sun is the natural source of light. Very good. Okay, next. What is the nature of the propagation of light? Curvilinear, rectilinear, random, or circular? It is. Yes, what about others? Quickly answer, everyone. It is rectilinear. Very good. Next. Image found by a plane mirror is virtual and erect, real and erect, virtual and inverted, real and inverted. By a plane mirror. Okay, those of you have answered correct. Plane mirror. Plane mirror is virtual and erect. Okay. Next question. What happens during lateral inversion? The right of the object will be on the right side. Left side of the object will be on the left side of the image. Upper part of the object will be at the bottom of the object. The right side of the object will be on the left side of the image. Correct, Ananya, Saswati, Rajat, Pratham, correct. Manasvi, correct. Yes, what about others? Come on, take a guess at least. Okay, yes, the right side of the object will be on the left of the image. All right. This one I am going to not talk about because this is too much, that'll take too much time. Okay. In a completely dark room, if you hold up a mirror in front of you, will you be able to see the reflection of yourself in the mirror? No. Because there is no light which is being reflected. Okay. All right. So that's it for this demo. I hope all of you understood everything, and I hope to see everyone in the regular classes, right? So in the regular classes, according to the schedule, obviously we'll start with the first chapter and eventually we'll come to this chapter and we'll continue, right? So that's it from my side today. I hope to see you guys in the regular classes. Okay. Bye, everyone. Thank you for your time. Bye-bye. Have a great day, all of you. Bye.